project, which is Palm TDS, also known as the Thermal Detection COVID Station. This is an outline of some key topics that we'll be talking about in this presentation today. And this is our team. I am Arturo Palomino. I am the team manager and software engineer, and I'm studying computer engineering.
I am Michael Ramlakan. I am the hardware lead engineer. I'm also studying electrical engineering.
I'm Peter Giordano. I'm the software lead engineer, and I'm studying computer engineering.
And I'm Leonardo Camaj. I'm a hardware engineer, and I'm studying electrical engineering.
So this is our project motivation. What inspired us to pursue this project is, of course, the COVID-19 pandemic. We want to uphold social distancing standards. And of course, we saw that the market for thermal sensors have been increasing in the past couple of years. So with this in mind, we want to create a more cheap and more effective thermal scanner and also improve upon the thermal and IR technology currently available. This is so that we can keep our community safe.
So the big picture here is that our social distancing standards aren't being met, and even when they are, it's very important to give users and institution organizers access to their body temperature so that they can make a medical decision based on it. It's also important to supply items such as face masks, sanitizer, and wipes to help prevent the spread of the disease. For objective, we want to make a cheap and efficient thermal station. We want a website that's easy to use and linked up with a database along with the station. We want the station to be accessible to all users, and not only that, but hands-free to also help prevent the spread of the disease. We want a thermal camera to give accurate thermal readings, and with all that, we hope to keep people safe. So this is the tree of our objectives for the project. And the important points is that we need everything to be easy to use. Like we said, we need our station to be hands-free, and we also need the website that goes with it to be intuitive. There also be output signals for the user on the display. For thermal imagery, the image taken needs to be accurately represented so it can be properly used. Users should be able to access them easily, and the user interface should be simple and minimalistic. And lastly, it needs to work efficiently. Mainly, the microcontroller needs to be cooled since it'll be on for long periods of time.
Here we have our related works diagram. It's a pros and cons chart related to with 3 related works on the left-hand side, which are the King County Metro Redo New York campaign, City Farmers Market thermal detection system, and the kiosk thermal station. The bottom row relates to our thermal imaging COVID station. With the creation of this chart, we hope to take the pros from all of the 3 related works and implement them into our project as best as possible while avoiding the cons. Just to briefly explain one of the related works, the kiosk thermal station is a thermal camera detection system with a subscription database. Some cons to it could be that it's a pay-to-use station. It's very high maintenance, and yeah, basically that's it. Here we have an AHP diagram related to also 2 new related works or current approaches: the mask of now vendor and the kiosk support stand. In the last column, we have our thermal imaging COVID station. On the left-hand side, we identified 3 features that we want to test to compare against the other 2 that we have in our AHP diagram, which are the design size, system tracker, and restock ability. We determined that the symptom tracker would be one of the most important features to our design, so we gave that one the most weight. And yeah, here are the results.
Some key takeaways from our project is what our project is developed to do. The main components of our project is, once again, to detect temperatures from the user while also storing that information and presenting it to them with easy access no matter where they are. We do this because we want to, once again, enforce social distancing standards. Some key ways we plan on doing this is using items that help keep a distance from the station, which are QR scanners and the motion sensors that we are going to implement later into our presentation. And a key takeaway that we want our project to do is to implement these social distancing standards while providing necessity sanitation items for the users. This is a quick engineering market trade-off matrix that we have showing the positive and negative correlations between items we deemed are necessary. For example, one key takeaway you can visually see from this chart is that there is a very strong negative correlation between the simplicity and accuracy of this project. One reason for this is because we are trying to detect body temperature using a camera that is connected to our Raspberry Pi. We're trying to get as little error as possible while detecting this, which is why there is a strong negative correlation versus strong positive correlation between power and accuracy. So these are just some system overviews. The first two images are um, basic design frames we had at the beginning of the project using OrCAD. This is just representing the back and front of the image. The images to the right are the few components that we have assembled together in order to maintain our project, which is the Raspberry Pi with the LCD touch display and a 1080p camera that can also detect uh, night vision mode along with the motion sensor.
So these are some related equations, mainly Planck's law, which calculates the total energy of a physical body. And we also need to calculate emissions and radiation power. And the reason these equations are important is because the thermal camera needs to detect heat signatures, and those come from emissivity, among other factors. And this is our behavioral module for the project. As you can see, it shows how the user in the lower left corner interacts with the station and how the station operates with all other electronic components in the system, namely the display, the thermal camera, the microcontroller, and the dispenser.
So here we have the functional decomposition level 0, and we have the module which will be the QR scanner. So it will take in a DC input and QR codes as an input, and the output would send information to the database and will toggle to turn on the camera. This function is basically meant to it could scan codes on the system itself, so it could be a hands-free experience, and more QR codes can be generated in the website. For level 1 decomposition, we have the website itself, which will take in user input, and it will display the user account and details. It will create a user account and will create a personalized QR code for that user, and they can keep track of their information on this website. The thermal camera will be taking DC voltage as an input in a human face, and it will output thermal images of the user. The way it will work is that the camera will take a picture of the person's face, and these pictures will be converted into thermal images. And the last part of the functional decomposition level 1 is the 7-inch LCD display, which will take in a user input, and it will display user data, account details, and more, and also any messages that has to be displayed for the user. And this will be the main interface for the station.
So for our hardware design, we have a demonstration video in the later slides, but some basic components that we have to get across is the Raspberry Pi microcontroller as the main microcontroller in our project. We're using the Raspberry Pi 3 Model 3 Plus. We're doing this with SD card and Raspbian downloaded on the system and the use of the terminal market to store images and present the data that is being used. We are also using the thermal camera. Specifically, it is a OV5647 sensor for the Raspberry Pi, obtaining 1080p pixels, and it has a field view of 72 degrees, which is very necessary for our project because we are implementing a motion sensor to activate the camera for the user to use. Once again, we have the LCD display for the users to interact with if necessary. Once again, we are trying to keep our project as hands-free as possible. To the right, we have a circuit diagram of the ESP32 and the PIR motion sensor, which is what we use to test our motion sensor. Due to COVID and traveling circumstances, we were not able to meet up as frequently and test this with the Raspberry Pi. So we did use the ESP32 to make sure that the multiple PIR sensors that we are using are operational.
So for software design, the main concern is to develop an easy-to-use website where users can create an account and get access to a unique QR code that they can use to log into the station. User data will be stored in a database that we link to both the website and the station. And for the station, the display will have a simple interface to it. And the microcontroller, of course, will be programmed to check taken temperatures and manage the database. The image on the right is a work-in-progress screenshot of our website, namely the Our Project tab, and it's an informational tab along with the About Us tab. But the main tab will be the Home tab, where the user can manage everything once they log in. And this image just shows a general layout for the website we want, but the overall look will change over time. And here's a video demonstrating our working hardware components and the website being used. Just note that the website isn't properly optimized for this device and the layout doesn't display correctly. This will be fixed.
One key thing to add in our video is this is a compilation of everything being tested. Right now, you are witnessing the thermal test activation between lights being on and off for dark users. Right now we have the QR scan test, which will be a code generated with a specific link. We are going to link this to our website so the user can have easier access, but this is just a demonstration of the Manhattan College website uses a QR code scan. Lastly, we have the website integration into the touch screen display for the user to use. As you can see, I am just scrolling through the website, seeing the functionality and observing if the website is accurate and presenting what has been coded by our coding team. So some iterations we had to perform for our optimal design is that we had to change the LED power source. We've done this because the Raspberry Pi outputs a maximum voltage of 5 volts, and we are having multiple components connected to our Raspberry Pi. Once again, we are having a LCD touchscreen display along with multiple PIR motion sensors that will operate along with the thermal camera. Because of this, we want easier integration and less power consumption. As our team has mentioned earlier, the CPU temperature of the Raspberry Pi has also become a problem because of how long the Raspberry Pi will be operating. So we have been working on a way to cool this. We've also performed multiple image processing techniques and segmentation techniques because once again, we are trying to determine body temperature because our camera gives very accurate and captive pixels. We were able to do this. As for software, we're still updating the website and performing how and analyzing how it will be processed on the screen, and we are creating charts for the user to see this information a lot easier. This chart shows the iterations test that I was talking about earlier. It's just a couple examples of what we have done. Specifically, one you can pull from this is the QR code scanner, which took the least amount of time, versus the IR camera, which took the most amount of time, because once again, the difference in their processes. This next slide is a testing results chart that we have done for the infrared camera. This is just step one, which was getting the camera to turn on and be integrated with the Raspberry Pi and show the 1080p resolution, which we are wanting. We've also were able to capture the image and save the image for the last 10 seconds. The next slide shows multiple steps. Once again, the thermal camera is still a work in process because we are trying to, once again, obtain accurate body temperatures. The last time we ran this test, we got a very high temperature, close to 5% error. So obviously, this is still something we are working on and trying to integrate into high accuracy readings. This
This is a project schedule. Basically, for our Gantt chart, we had to create a project outline with tasks and subtasks. So the main tasks are the design phase, hardware, software, and design review phase. And then listed under all of those main tasks, we have subtasks based on and all the subtasks have start dates and end dates. The Gantt chart is going to help us organize the project uh, and create timelines for subtasks to be completed. And here for the next picture, we have an actual full Gantt chart. The red line at the bottom indicates the 40% milestone, which is the current data today. In our 40% milestone, the hardware was able to design blueprints, test parts, and integrate the website, whereas the software was able to design, create a website, and upload the website to microcontroller.
So here we have our go and no-go milestone, and what we set out was to have a ready and functional website, finalize the blueprint designs, and have all functional hardware. So the way we performed was that the website is functional with some improvement needing to be made without the signing capabilities. The blueprint is mostly finalized, but we'll be touching about this more on next semester. And all major parts have been tested and acquired successfully. But however, not every part has been acquired, and this can be attributed to the COVID-19 pandemic, as some parts have been delayed or some parts not being able to be accessible or bought. And the website and the database will definitely be worked on during next semester. Here we have our cost analysis. Some key takeaway here would be the Raspberry Pi itself, the touch display, and the camera itself. Some of these products were provided to us by Dr. Wang, which is why we zeroed them out, and our total came out to be $182.82. This is definitely a good and cheap and effective system if we can keep it within the budget. So, yeah. And here we have our conclusion. Although in our capstone project, we developed a new understanding of developmental research and teamwork as engineers, we definitely learned a lot of several new skills such as HTML and CSS programming for the website development. And we were able to create large-scale projects based on a Chrome-wide theme, which is in this case the pandemic itself. In the future, we definitely want to find a new source of power for the system because the microcontroller itself can only take in up to 5 volts as input, which definitely will not be enough to power the whole system itself. We also need to prevent it from overheating, as stated earlier. And in terms of software, we have to finish updating the visual design of the website itself, create the database, and basically integrate everything together.
For our codes and standards, basically, since this is a thermal imaging COVID station, we had to look at some health and safety codes for New York City. After going through a couple of the codes, I made sure that I got 4 of them that would apply to our project. Mainly, these 4 codes describe how the program should, how it should be reporting coronavirus cases and providing isolation chambers for people that are positive or have symptoms for the coronavirus. And also we have a couple of standards that are listed here: the IEEE 802.11 and the ISO 14882. And for the last one, we have ethical analysis. So basically, with the project, we plan to target large institutions such as colleges and college universities and work environments. I think that our project will best thrive in these environments. Some potential ethical issues that may arise from the project could be the privacy issues. Obviously, people are going to be entering personal information into the program, entrusting the program to keep recordings private between the system database and the user. So we're going to try to avoid these ethical concerns. We would like to make display messages and visual images that comfort the user and make it as user-friendly as possible. And to relate to the slide before, we also want to explain some of the IEEE codes that are applied to our project. And just to name one briefly, from the Gantt charts and the mock simulations of the website, you can see that before we are due to complete a task, we like to test and make sure that we are able to complete the task and then apply it to our project. Yeah, these are some of the references that we use. Thank you.
Any questions?
Yes, I have a question. From which part of the body you're measuring the temperature?
It's going to be from the face up. Mike, maybe you want to elaborate on that?
Yeah, similar to the previous group, we're developing a integration recognition software. Well, mostly we're trying to research this of the different conditions of face mask, and we're trying to understand how to integrate that.
Mm-hmm.
What differs from the previous group, this study?
In their group, they talked about measuring people entering and leaving a building. Ours more like an actual station where people will come in and scan themselves to get a temperature read. If a high temperature would be recorded, they'll be told to quarantine, and maybe we could potentially add some software that could send an email to any public safety departments in the nearby area, alerting them that a high temperature scan had been sent.
You don't measure temperature through the palm, correct?
No.
Excellent, good. Okay, so I understand your difference is functional mostly with the other studies, mostly functional.
Also, we have integrated sanitation devices that we wish to implement. So we're trying to create our own hand sanitizer with the PIR or motion sensor, along with a touchless face mask dispenser with it. We have purchased a Adafruit hat motor and a wheel-based mechanism to implement a ATM styled dispensing for our face mask, which we are going to also put into our system.
I see. A very good study.
Thank you, Dr. Gakos. Thank you, everyone. Have a good day.
Palm is just our first initials grouped together. We're not actually doing anything with the palm.
Mm-hmm. Thank you, everyone.
Yeah, thank you. Thank you, Dr. Gakos.
Okay, thank